So go to stats and edit, enter, clear L1, clear L2, clear, and we have 2, 4, 6, 8 for X, 2, 4, 6, 8, and exactly the same order, 13, 7, 7, 3.7, and 1. Okay, if I want to see this, I need a totally different viewing window. 0 to 10 will be good for both X and Y. 0 to 10 with a scale of 1, 0 to 10. Always have to adjust the viewing window based on the data. And 1. So now I want, I already have these, everything is turned on for the stat plot, so I just want a graph. Sorry. I have to go back and eliminate this. So it appears that this is an exponential function with a base less than 1. Okay, so now we go to stats, calculations, go up, it's better. So we go to exponential regression, which is 0. List L1, yes. List L2, yes, that's correct. I want you to enter the function already for me. Please do. Okay, and then calculate. So here it is. As I expected, the base is less than 1 because the function is decreasing. So now y equals 34.3947 times 0.65927 raised to x. So now we can look at the graphs. It will graph the function and the points as expected. So this is the function that has the smallest error, will not pass through the points, but has the smallest error possible. Minimizing using calculus. Minimizing the error using calculus, the squared error. Okay, that's all I care about section 6.4. I do not want you to do any calculations by hand because we have the calculator. And I know I only have like 8 minutes left, and in 8 minutes I just want to present the intro to this chapter, and then I'll stop, I promise. Oops, it's 11. So chapter 6 is all about functions of multiple variables. In other words, we do not have f of x equals x squared plus 2x minus 1, but f of x and y and z. For example, with 3 variables, like x squared y plus 3xyz minus 4yz to the third. This is a function of 3 variables, 1, 2, 3. So all I would like to do now is just would like you to choose from page 531 to evaluate. That's all 6.1. How to evaluate functions of multiple variables or several variables. Evaluate. How do I evaluate? Exactly how I evaluate this. For one variable, I evaluate this for any variable. So just give me 3 values, what you would like to evaluate this function that I just made up, or we can choose a problem from the book. Just choose any values for x, y, and z.
2, 4, and 6.
2, 4, and 6. Awesome. So f of 2, 4, 6 is 2 squared, 4, times 4, plus 3, times 2, times 4, times 6, minus 4, times 4, times 6 to the third power. That's it. There's my calculator, so I don't have to share. So this is 16 plus 5 times 6 is 30. 4 times 30 is 120. Minus 16 times 6 to the third power. I got negative 3320. That's it. That's all there is in section 6.1. We're just evaluating. So please choose on page 531 any problem you would like to look at. They're all the same thing. What about, would you like to look at 5 or 6? Or any function, really?
You just do 6.
6 it is. 6 on page 531. And we have a function with only 2 variables here, which is 2 to the x minus 3 to the y. Okay. And they're asking us to evaluate. Choose which one. Would you like f of 0, 2? Would you like f of 3, 1? Or would you like f of 2, 3? Or 2 of them or all of them? Up to you. So when I plug in 0, 2 to 0 is 1. When I plug in 2, I get 3 squared, which is 9. So the first one is negative 8. 3. 2 to 3 is 8, minus 3 to the first, which is 3, so this is 5. 2, 3, 2 squared, 4, minus 3 to the third, which is 27, negative 23. And that is it. Any questions on this? Final question. Promise. I would like to find the domain of this function. Just 14, last problem. We're given a function of 2 variables, and it's 1 over x minus y over x minus 1. We've done this a long time ago. We know that x cannot be, and this x cannot be.
X cannot equal 0.
Yes, and here x cannot equal
1.
Good. There is no restriction on y. No restriction. So I will say the domain of h, x comma y, is, and we write it as ordered pairs, so any ordered pair x comma y, no restriction, I don't have anything to say about y, any y if you want, but x cannot be 0 or 1. You don't have to write this part. I just wanted to emphasize. So there is no restriction. We don't write, if there is no restriction, we don't have to write this. So it's any ordered pair. This bar stands for such as, or having the property. Either one. That x is not 0 or 1.